Hi everybody, my name is Paolo Gai from Evidence. This video will guide you in the usage of the software developed in the AXIOM project. The AXIOM project aims to the creation of an embedded board which can be connected together with other similar boards in order to create a cluster configuration. We developed a common programming paradigm based on OpenMP and OmpSs Cluster, and we use it in video and audio processing application use cases. In this video, we will emulate the cluster configuration using QEMU virtual machines, which will emulate the Zynq ultrascale plus nodes of the cluster. The QEMU virtual machines are connected together using a virtual switch that is used to emulate the routers implemented in the Zynq FPGA. The software used in this video has been packaged in a VirtualBox virtual machine to ease its deployment and distribution. We are now starting the QEMU virtual machines using a makefile. The parameter VMS can be used to specify the number of QEMU nodes to run. The connection is by default configured as a ring topology. Please note that a Linux build root automatically starts once the QEMU emulator started. You can see the QEMU now started and the windows are just running Linux in their respective windows. We can now start on each virtual machine the AXIOM Network subsystem. This script basically loads the kernel modules and then launches AXIOM-init on all nodes. Basically all nodes except one starts AXIOM-init in slave mode, while one of the nodes starts the AXIOM-init in master mode. Once the master node started, the discovery algorithm is run and the routine tables are printed and distributed to all nodes. At this point, it is possible to use the AXIOM utilities. The first utility we show is axiom-whoami, which is able to tell you which is the current node. And there is also axiom-ping, which is an utility which can be used to measure the communication latency between the two nodes. The second utility that we want to show you is axiom-netperf, which can be used to measure the bandwidth between two nodes. Other utilities are available as well, such as, for example, the traceroute, send and receive messages, and so on. We are now able to show you how to cross-compile an OmpSs application for the AXIOM cluster. We open a terminal in the host, and now we cross-compile using a script, two small demos, a matrix multiplication and an NBody simulation. At this point, the application has been compiled, and we can use a script to copy the binaries inside the QEMU virtual machines file system. Once copied, we will use the AXIOM run spawner to start the application on all nodes of the cluster. We can now launch the matrix multiplication using AXIOM run. You can see on the output of the matrix multiplication that the node ID is printed as the first number of each line. So these are the output coming from the execution of the application on the various nodes. As the result of the execution, an Extrae trace file is generated on each node. Use then a script to collect the Extrae trace files from the QEMU virtual machines. The traces are copied and merged inside the host machine. At this point, the PARAVER viewer can be launched to show the execution of the application on the various nodes. We are now launching PARAVER, and the output will be a graphical representation of the execution of the matrix multiply. The middle window can show you the task which has been executed by the execution of the application, and the first one are the function calls which are executed. We can zoom on them, and once we zoom on them, we can see that there are various calls which are being written as RDMA and as send of messages using the Axiom interconnect. We are now removing the set0 directory, which stores the previous traces which were recorded by the previous run. We can now launch the NBody example. The execution is quite long and the video has been cut for simplicity. Again, we are using the script that you have seen before to collect and merge the Extrae traces. Finally, we have again a PARAVER trace with the representative of the NBody demo execution. Here we want to highlight the messages sent to the GasNet conduit used by OmpSs. Okay, we can now launch PARAVER to show the execution trace of the NBody example. Okay, we are now zooming a small part of the execution, and as you can see there is axiom send row and other primitives which are executed inside the GasNet conduit, which has been developed as part of the AXIOM project together with the OmpSs at Cluster. Thanks for watching this video, and for more information please visit the AXIOM website. Bye bye.